Good morning, students. In this session, I am going to discuss the rules for oxidation number. So, few of the rules we will discuss already in the previous video. Let's discuss the next for the rules of the finding the oxidation number of the species. So, rules for assigning oxidation number. So at first we discuss about the interpretation of covalent bond. Interpretation of covalent bond. Suppose we have compound E and B and E and A. B is more NB is the more electronegative than Na. So in that case, we know that shared electrons are assigned to the more electronegative element. So suppose we have few cases and oxidation number of A and oxidation number of B. Suppose we have a simple covalent bond AB, and as we know B is more electronegative than A. In that condition, oxidation number of A acquired +1 and oxidation number of B acquired -1. Next one is A and B form double bond. In that condition, 2 electrons shared between these species. So which one will be more electronegative? Both the electrons assigned in the form of charge. So it acquired +2 and it acquired -2. If A form triple bond with B, similarly 3 electrons shared between them, so -3 acquired on the B because B is more electronegative, and +3 acquired on the A. So if we have a compound AB in which dative covalent bond is formed, we know that in dative bond both the electrons, one pair of electrons denoted by one of the species. So A donate the electron to the B. In that condition, 2 electrons donated by A. It is a type of covalent bond, dative bond. So it acquired +2 and it acquired -2. But what happens if AB form in which B donate the electron by making the dative coordinate covalent bond? In that condition, as we know, B is more electronegative than A. So whenever B donate 2 electron to the A, being electronegative, it pull the electron towards itself. In that condition, both the species acquire 0 charge, because it does not gain and it does not lose because it is more electronegative. So after losing electron, being more electronegative, it pull the electron towards itself. So in that condition, we see a simple way to interpretation of covalent bond. How can we assign the oxidation number of particular species? So let's discuss next. Shared electrons assigned, as we know, more electronegative element. Shared electrons always assigned to the more electronegative element. Calculation of oxidation number. Calculation of oxidation number in covalent bond. Covalent bond. Interpretation. Suppose oxidation number of N in HCN. One example is given here, and another example to find oxidation number of N in H and C. Hydrogen isocyanide and hydrogen cyanide. At first we draw the structure H triple bond, and in that case hydrogen form hydrogen, nitrogen, double bond carbon, and one coordinate bond also formed with nitrogen and carbon. So how can we assign the oxidation number on particular species? As we know that carbon is more electronegative than hydrogen, so +1 charge appears on the hydrogen and -1 appears on the carbon. Nitrogen is more electronegative than carbon, so nitrogen acquire -3 charge and carbon acquire +3 charge. +3 -1, total charge present on the carbon is +2. So if we find out the oxidation number of nitrogen, so it comes -3. Simple. In case of hydrogen isocyanide, let's find out hydrogen is less electronegative than nitrogen. So hydrogen acquire +1 charge and nitrogen acquire -1 charge. And nitrogen is more electronegative than carbon, so it also acquire -2 charge. And nitrogen donate 2 electrons, but being more electronegative than carbon, so 0 charge. No charge acquires on the nitrogen and also on the carbon in case of dative bond. But in case of this 2 covalent bond, this is 2 covalent bond, one is here and one is here. Due to this 2 covalent bond formed between the nitrogen and carbon, so nitrogen acquire -2 and carbon acquire +2. So still nitrogen acquire -3 charge on it. So in that way you can find out the simply carbon +2, nitrogen acquire -3 and hydrogen acquire +1. So simple way to find out the oxidation number on particular species. Let's discuss the fractional oxidation states. Fractional oxidation state. So our next topic is fractional oxidation number or state. To find the oxidation number of Fe in Fe3O4. How can we find out the oxidation of Fe in Fe3O4? Because we know that Fe3O4 is formed with FeO and Fe2O3, ferrous and ferric oxide. Ferrous oxide and ferric oxide. By combination, this is called the mixed oxide. So let the oxidation number, suppose we find out, let the oxidation number of iron Fe, suppose be X. Find out the X. So 3 oxidation number of Fe plus 4 oxidation number of O equal to 0. So it comes 3x and plus 4 minus 2 equal to 0 and x plus 8 by 3. Simply we can calculate this form also. Or another simple method if you know, so you can find out the way to find out the fractional oxidation number. So in this way you can find the simply plus 2 plus 3. Suppose if this is plus 2, this is plus 3, and if this is plus 2 by average, if we find out the, suppose we find out the average oxidation number. So Fe here is the plus 2. So 1 Fe is in the state of plus 2 and this 2 Fe in the plus 3 state. So by calculating you can find out the oxygen is 3. So this comes plus 8 by 3 simply. So plus 3 plus 2 plus 2 plus 3 plus 3 you can write in this way also, plus 3 and plus 3, 2 times Fe. This is plus 2, this is plus 3 and plus 3. So by calculating, plus 8 by 3. Total number of atoms, sum of oxidation number of all atoms of the element. So and the total number of atoms of the element. So you can find out the fractional oxidation number of the this type of molecules also. Let's find out the oxidation number of few molecules. So it's you're in your NCERT book. So many examples are given. Try to solve. Next one is, suppose we oxidation number of sulfur in H2SO5. This molecule is known as Carose acid. Carose acid. Carose acid. So at first we draw the structure of the H2SO5. Sulfur 1, 2, 3 and 4, O and H, one coordinate bond here, one coordinate bond here, and O, O and H. So 1, 2, 3, 4, 5 oxygen, 1 sulfur and 2 hydrogen. So find out the oxidation number present on the particular species. As we know, oxygen is more electronegative than hydrogen. So here is the -1, here is the +1. And this is already electronegative than sulfur, so here is also -1. So total -2 assigned here, -1, -1. In that way you can calculate, and here is -2, here is -2, and this is the peroxide. So oxygen is more electronegative than sulfur, so it requires -1, and this is more electronegative than hydrogen, so it also requires -1, +1, and sulfur. On sulfur, total number of oxidation state is plus is 2, 2, 4, 5 and 6, total plus 6. In this way you can find out the oxidation number of, so oxidation number of sulfur in this molecule is plus 6. Next one is the Marshall acid. Sulfur in H2S2O8. This is known as Marshall acid. Marshall's acid. So draw the structure of H2S2. So one sulfur here, one sulfur here, 1, 2, 1, 2, 3, 4, 3, 4. So assign oxygen, hydrogen, H, oxygen and oxygen. So simply oxygen is -2 oxidation state, here is also -2 oxidation state, -2 oxidation state. This is the peroxide, so -1, -1. This is -2, +1, -2, +1. So count the total number of oxidation state on the sulfur, 2 to 4, 5 and 6 plus 6, and here is also plus 6. So oxidation number of sulfur is come plus 6. Next example we discuss it called chromium oxide, which is also known as a butterfly structure. So let's we discuss the third example, oxidation number of chromium in chromium oxide. Very important. Number of times the oxidation number, find the oxidation number of this particular. So at first draw the such a chromium with 1, 2, 3 and 4. Mostly students assign -2. So 5 to the 10. So assign the chromium plus 10, which is extremely wrong, because chromium belongs to this group. Its maximum oxidation number is equal to the group. So at first find out the type of oxygen. So here the oxygen in the form of peroxide. So -2 assigned for this oxygen, and -1, -1, -1 and -1, because oxygen is a peroxide linkage. So count the total number of oxidation state on the chromium. So here the +1, because oxygen is more electronegative. Here is also +1, because oxygen is more electronegative, 1 electron between them. And here is the also +1. Here is also +1. 1, 2, 3, 4 and 2, 6. So total number of oxidation state is a 6 on the butterfly structure of chromium. Similarly, oxidation number of chlorine in calcium oxychloride. Calcium oxychloride, calcium +2 charge, 2 chlorine, 1 is like this, and OCl 1 -1, and oxygen is more more electronegative than chlorine. So in that condition chlorine acquire +1 and this acquire -2 charge. So overall charge present on the, find out the, suppose we like this, suppose OCl and minus charge. So find out the -2 and +1. So -2 and chlorine, suppose we find out the oxidation of chlorine. So we take as a X, and overall charge present on the species is -1. So it comes X equal to +1. So in this way you can find out the chlorine in calcium oxychloride. In calcium oxychloride there is a 2 chlorine, one acquire -1 charge and another chlorine acquire +1 charge. It is known as, so we can write here chlorine -1 charge and OCl +1 charge. So it is known as a hypochlorite ion. Hypochlorite ion. So oxidation number, find out the oxidation number of so many species given in your NCERT book. Let's discuss the balancing of redox reaction. Next topic is the balancing of redox reaction. So it involves first balancing atoms, second balancing charge, and balancing electron lost or gained. Balancing electron lost and gained. So we will discuss two methods: oxidation number method and second half reaction method. At first we'll discuss the oxidation number method. Balancing reaction also involves medium acidic or basic. Next topic, next one is the balancing a reaction also involve medium acidic or basic or neutral. So write down the steps involved. At first we'll discuss the oxidation number method. Oxidation number method involves following steps. Step 1. Calculate the oxidation number of all elements and balance the atom. Balance the atom of element whose oxidation number changes. Balance the atoms of elements whose oxidation number changes. The first rule. Second step is step 2. Find out the total oxidation number change. Find out the total oxidation number change of all elements and balance the electron lost with electron gain. Step 3. Balance the charge using the medium given charge, using the medium given. Suppose acidic medium for H plus, alkaline medium for alkaline or basic medium, use OH ion. Acidic medium, alkaline or basic medium. Balancing oxygen and hydrogen. Balancing of hydrogen and oxygen atom. Alternative step to step 3. Alternative to step 3. Acidic medium. Hydrogen atom. Add H plus to the site lesser in H. lesser in hydrogen. Oxygen atom. Add H2O water to the side lesser in oxygen. For basic medium. For basic medium. Basic medium for hydrogen atom, balancing hydrogen atom, add H2O to the side lesser in H and equal number OH ion to the other side. For balancing oxygen atom in basic medium, add to OH ion to the side lesser in oxygen and water to the other side. Let's be explained with the example. For example, Cr2O7 minus 2 iron plus 2 react to form chromium 3 plus and Fe 3 plus and water. Balance this equation in acidic medium. So student, at first write down the step 1. Indication of oxidation number of each atom. At first, indication of oxidation number of each atom. First step. So Cr2O7 minus 2. So chromium plus 6 oxidation number, oxygen minus 2 oxidation number, plus iron also plus 2 oxidation state, chromium in plus 3 oxidation state, Fe plus 3 oxidation state, and water oxygen minus 2 and hydrogen plus 1. Next step, step number 2. In step 2, writing the oxidation reduction half reaction. So oxidation and reduction half reaction. So at first, reduction half reaction. Reduction half reaction, Cr2O7 minus 2 chromium plus 6 minus 2, so plus 3. So chromium goes plus 6 to plus 3. So there is the decreasing of charge takes place. This is it. So here is the reduction of chromium takes place. So balancing the charge by putting the suitable stoichiometry. So in that condition, both the charge becomes equal. Number of atoms also equal. So oxidation half Fe2 plus changes into Fe3 plus. So both the number of atoms is equal. So at first we balance the number of atom. Next we balance the number of electrons or charge assigned on it. So step 3. Step 3. Adding electron adding of electron to make up the difference in oxidation number, to make up the difference in oxidation number. So Cr2O7 minus 2, so plus 6 minus 2 and changes into Cr3 plus. So here is the total 6 charge present, so here we will add plus 6 electron, so make the charge equal, because each chromium atom gains 3 electron, thus 2 chromium atom will gain 6 electron. So in that condition we first balance the number of electrons. In case of Fe2 plus changing into Fe3 plus, so here one electron written in this side, so that their electrons becomes equal. Next step means step 4. Now step 4, balancing oxygen. At first we will balance the oxygen in acidic medium. So balancing the oxygen by adding equal number of water molecule, to the side which is deficient in oxygen atom. So here is the 7 oxygen and here is the only 1 oxygen. So number of H2O molecule is added to the side where the deficiency of oxygen atom. So Cr2O7 minus 2 plus 6 electron to Cr3 plus 7 H2O. Equation is only this to this, or either you can write H2O also. And in case of iron, there is no oxygen atom. So now step 5, balance hydrogen by adding H ions, to the side which is deficient, in hydrogen atom, So Cr2O7 minus 2 plus 6 electron and 14 H plus, because 14 H plus because here is 7 water molecules present, 7 H2O. So this side is deficient hydrogen atom, so 7 2 are 14, so 14 H ion is written in this side which is deficient in hydrogen atom. And Fe2 plus changes to Fe3 plus and 1 electron. So balancing the number of electrons by putting suitable stoichiometry. So this becomes cancelled and final Cr2O7 minus 2 plus 6 6 Fe2 plus 6 plus 14 hydrogen ion and 2 chromium 3 plus 6 Fe3 plus and 7 H2O. So students, in this way you can balance the equation, ionic equation in the acidic medium. So in the next video we will discuss the balancing equation in the basic medium. Till then you can prepare or do practice by balancing the equation in the acidic medium. So it is very important, and find out the oxidation number questions from the NCERT book also. That's enough for today. Thank you.